Okay, so we did the four double angle identities. Okay, we have one for sine double, three for cosine double, right? And then we used it on the homework, right? To try to express a single and try to find exact value. Let's go over the other identities, okay? So we complete the list. So the other two identity that we need is called the quotient identity and the square identity, okay? So these two, we won't be using it for the homework today, but it will be on the quiz for next time, okay? So then, because next week's lesson will need all the identity, okay? So that's why I give you a week to memorize those ones. So for quotient identity, quotient means dividing, okay? So you can see that sine A over cosine A, if you see those two combined together, angles are the same, okay? Then it can become tangent. You can simplify it, okay? So for example, if you see sine of pi over 3 divided by sine of pi over 3, sorry, cosine, right? Cosine pi over 3. Then this fraction can simplify into tangent of pi over 3. Okay, we can check, okay, see if it's true, okay? Let's check. So if it's pi over 3, let's put the angle here, pi over 3, okay? How long is the opposite side? Okay, if the angle is pi over 3, how long is the opposite side? Opposite side is this red one. Angela?
Pi over 6. Oh, sorry, the side.
Yeah, opposite side to pi over 3.
Root 3.
Yeah, very good. Okay. So that one root 3, so that means the other one will be 1 and 2. Okay. So what we are going to do right now to check is we look at the left side, okay, the green part. So sine of pi over 3 is root 3 over 2, right? Opposite over hypotenuse. That's for the numerator, right? Divided by cosine. Cosine of pi over 3 is 1 over 2. Okay, the numerator is root 3 over 2, denominator is 1 over 2. So if you divide that, right, divide it will be, when you divide a fraction, you need to multiply reciprocal, right? The two will reduce each other, so it becomes root 3 over 1. And root 3 over 1 is just tangent, right? This is tangent. Okay, this part is the sine pi over 3 divided by cosine pi over 3. Okay, so you can see sine angle divided by cosine angle, it can become tangent of the same angle. Okay, this is just checking, okay, that it works. So similar for cosine over sine. Cosine over sine means you flip it, right? Reciprocal. So tangent reciprocal will become cotangent. Okay, so those two are related. So if you remember the first one, you remember the second one. Okay, any questions? Okay, can you raise your hand if you copy the notes down here? And then we're gonna look at the square, okay? You can raise your hand after you copy the notes down. Okay. Evan and Jocelyn. Okay, Jocelyn, do you need more time? Jocelyn. Okay. So let's look at the next group. Okay, next group is also very useful. Okay, very common. So it's called the square identity. Some textbook they call it the Pythagorean. Okay, identity. Okay, so it has to do with the Pythagoras. So we are going to use this picture on the top right here. This is an angle, right, in the first quadrant. So it doesn't matter which quadrant it turns to, right? If it turns to the second quadrant, right? If the angle turns to the second one. Okay, let me zoom out a bit. Okay, if it turns to the second quadrant, it still has the three sides like this, X and Y and R. Okay, so the adjacent, if it's second quadrant, adjacent will become negative, but opposite, the Y will be positive. Okay, so the sides will have change of positive, negative, depending on the quadrants. Okay, so that's why we have the ASTC, right? In different quadrant, different signs. So it doesn't matter where you put the angles, you always have a right triangle, right? For your reference angle. So from here we have X, because it's right triangle, we have the X squared plus the Y squared will equal to R squared. Right, that's from the Pythagoras. So we are just going to prove the first one, okay? The other one can be proved with the same way, right? So let's say we just look at the first quadrant. The angle is in the first quadrant here, okay? So opposite side is the Y. Adjacent side is the X. Hypotenuse is the R, okay? Like the radius R. So here we have sine squared, right? So sine square A. So that means sine A squared. They mean the same thing. Cosine A squared. So we want to somehow turn this into one, right? The identity tells us that if you add them up, you square them and add them up, they should equal to one. So how is that possible? Okay, so let's go over the steps. So sine of A will be opposite over hypotenuse. So from the picture, it will be Y over R, right? Opposite is Y. R is the hypotenuse, so Y over R squared. Okay, what about cosine? Cosine is what over what, Nick?
Adjacent over hypotenuse.
Yeah, so from the picture, it will be what over what?
X over R.
Yeah, X over R, very good. Okay, adjacent is the X over R. And then we have squared, okay? So we want to show that this thing will somehow become one, okay? So we'll simplify this. We will share in the square, okay? The square will go in, okay? If the inside is dividing or multiplying, then you can share the square. you have y squared over r squared, x squared over r squared. They both have the same denominator, right? So you could add them up. So on the top, now you see y squared plus x squared. What does y squared plus x squared equal? Jenny? What does y squared plus x squared become?
R squared.
Yeah, very good. Okay, so from here, right? On the picture, it's Pythagoras becomes r squared. So you get r squared over r squared. So that turns out to be 1. Okay, so there you go. It shows you that it doesn't matter which angle you are, which quadrant the angle turns to. If you use the reference angle, right, the right triangle, you will always end up with 1. Okay, you get sine squared plus cosine squared will equal to 1. Okay, it helps you to simplify. Okay, so please copy this notes down. And then this identity is not limited to this, okay? Sine squared plus a cosine squared equal 1. The left side equal to the right side, right? But you can move them around. It will still stay equal. So what I mean is, for example, I could move the cosine squared to the other side, okay? Kind of like equation. You can move things around. They will stay equal. So you could have sine squared A will equal to 1 minus cosine squared A, right? We just move the cosine squared to the other side, okay? Or I could move the other one. I could move the sine squared, isolate the cosine squared, right? Then you would have 1 minus sine squared. Okay, so from one identity, you can derive the other two. Okay, so these three are the main one. Okay, the one I highlighted. All right, so I would like you to try isolate, figure out the other two. Okay, so for example, the next one, okay, I would like you to find out what's tangent squared. Right, because now you have the secant squared, right? So find out what's tangent squared look like. And what's the 1 look like? Okay. Same thing with the cotangent ones. So find out what's cotangent squared look like. Find out what 1 equals. Okay, so find the other two for each identity. Okay, once you've done that, you can raise your hand and we'll check them. All right. If you are confused on what to do right now, let me know. Okay, let's check one of them first. Okay, you should have at least one of them. Tangent square A. Okay, Chris, do you have that one? Tangent square A. Chris, I cannot hear you. It still doesn't come out, your mic. No, not yet. Broken. Okay. How about you type it out? Yeah.
You hear me now?
Yeah. Now it's
Okay.
good. Okay, I can hear you now.
Is it just tangent squared A equals to secant squared A minus 1?
Yeah, very good. Okay, you move the one over. Okay, very easy, right? Just isolate each part. Okay, and Philip, what about the second one? 1 equals.
1 equals secant squared minus tangent squared.
Yep. Okay, so don't forget on the quiz, right? Remember to write out the data or A, okay? Don't forget the angle. Please raise your hand if you got the other two, okay, the last two. So in the future, if you see like secant square minus tangent square, and the angles are the same, you know it will become 1, okay? You can simplify. Sine square plus cosine square will equal to 1. So right now, just remember these ones, okay? Next week, after you memorize these ones, more familiar, then we will do some questions, okay? Okay, Waylon, what's the identity for cotangent square?
I got cosecant squared A minus 1.
Yep, very good. And Jenny, last one.
Cosecant squared A minus cotangent squared A.
Yep, very good. Okay, so please raise your hand if you finish writing all the notes here. And then I'm gonna help you memorize it, okay? Because you don't need to memorize all 9 of them, right? Because 2 of them come out from each one. So you just remember the yellow ones, okay? The ones I highlighted. The other one you can just derive if you need to, right? If the if you want to find them. Okay, so how do we memorize them without mixing up the order, right? So I use a hexagon on the right side. Okay, everyone see a hexagon on the right side? So for the first pair, okay, first of all, you write a 1 in the middle. Okay, first identity, you have sine square theta, right? Sine squared plus cosine squared theta, right? It should equal to 1. Okay, so in that there's a kind of like a triangle. Okay, they are a group. Now on their opposite side, okay, sine squared on the opposite, remember reciprocal, right? Sine reciprocal is what? What's the reciprocal of sine? Daniel?
Cosecant.
Cosecant. Okay, so on its opposite side, you'll put cosecant squared. Okay, And Susan, what's the opposite side of cosine?
Secant.
Yeah, so on the opposite, you put secant square. Okay, and then the last one, of course, the tangent and cotangent. Okay, tangent, we are going to put it on the left side. Okay, so cotangent on the right side. Okay, everyone got the picture filled in? Now all you need to do is just look at the three shaded triangle. Okay, we have sine squared plus cosine squared equal to 1. You go clockwise. Right, sine squared plus cosine squared equals to 1. That's the first one. Second one, tangent squared plus 1 equal to secant squared. Right, and then 1 plus cotangent squared equals to cosecant squared. You just remember the three triangles. Then you got the three identities, square identity. Okay. So please fill that in. Okay, after you've done that, please raise your hand. So usually I just picture the, imagine the picture in the head, right? Then I can remember all the three, okay? So you can try, close your eyes, see if you can see the hexagon. Remember the location, okay? Where is sine, where's cosine, where do you put the tangent? Okay, you have 1 in the middle, okay? So try to picture that in your head. And on their opposite side, right, you will have cosecant, you have the secant, you have the cotangent. Once you got the locations correct, then the identity is there, all right? Okay, please raise your hand if you finish all the notes here. This hexagon very useful, okay? Later in calculus, we also have the same picture, okay? With little modification, right? To help with a different identity, okay? Okay, please raise your hand if you're done copying. Eric and Evan, do you need more time?
I'm almost done copying. Excuse me. I'm almost done copying.
Yeah. Okay, so let's go to page 1 now. Okay, everyone turn to page 1. So everything on the left side is the identity, okay? Trig identity. So quotient, still remember quotient? Okay, what's the identity for quotient? Sophie?
Can you hear me?
Yeah, I can hear you.
Okay. Sine A over cosine A equals tangent A.
Okay, very good. I'm gonna use data instead, okay? So sine data over cosine data is tangent data. Okay, and then we have the reciprocal. So you flip it, right? Cosine over sine will equal to Claire. What's the cosine over sine? Claire,
Wait, it's tangent.
if it's sine over cosine. But
Oh,
if I
sine.
flip it,
Wait, you're lagging a little for me.
yeah, so if you flip, you do the reciprocal, right? What does
Yeah.
it do?
Sine. Wait. Oh, which part are we on?
We're on the quotient. Right here. What should be here? Cosine over sine should equal to what?
Oh, cotangent. Oh, cotangent.
Yeah, cotangent data. Okay. So you reciprocal, right? Reciprocal the left side. And at the same time, you reciprocal the right side. Okay. And then square identity. All right. So square identity, you can use the hexagon. Okay. There's sine square theta plus cosine square theta, right? Based on that picture, don't fill in the don't fill into the hexagon. Okay, try to look at the hexagon and then just say out the identity equals to 1, right? That's the first triangle. Okay, you have the second triangle, you have the third triangle. All right, Evan, what is the second one? Square identity. Evan?
Is it tangent squared A plus 1 equals secant square
Very
A?
good. Yeah, okay. So tangent square theta plus 1 equals to secant square. That's from the second triangle, right? Left corner. And then the last one, Calum.
Oh, 1 plus cotangent square theta is equal to cosecant square theta.
Okay, so these two groups, okay, you'll add it to your list. Okay, so next week, when you come into the class, we'll do this quiz again. Okay. So basically, you need to write out everything on the left side. Okay. So today we won't be using identity, okay? I just go over what they are, and then use this week, spend this week to remember those, and then next we will have questions on them, all right? Okay, please raise your hand if you finish writing in onto your formula sheet. Okay, so let's go to our main lesson today, okay? So back to here, we haven't learned anything new yet, right? Just went over the identity. Well, those are new things too. Okay, we are going to skip a few pages, okay? Because those are for identities, okay? So we're going to jump. We'll come back to there next week. Jump to page 75. It's called the trig equations. Okay, page 75. So the beginning part of this is something you already learned before, okay? Is when you learn how to find angles. Because equation means you need to solve for something, right? Like for example, if it's 2x plus 1 equal to 5, and you want to find the x, right? You need to solve for x, right? Find out what x equal, right? So this is called an equation. Solve for the unknown. So if we have a trigonometric equation, that means you have sine, cosine, tangent, right? Secant, cosecant, cotangents. So the thing that are missing is the angle. Okay, so when you're solving a trig equation means you're finding the angle. Find angles. So I don't know if you remember, find angles. We have find exact values and also find angles. Please take this time, okay? Go back to the notes. I don't remember exactly which page we learned that. Find angles. We had 4 steps. Okay, so if you forgot the 4 steps, check the notes. If you found the notes, you can raise your hand, okay? Let's review the 4 steps. We'll need that here, okay? It's in the part 1, okay? When we learn find exact value, and then the backwards is find angles. If you're able to find that page, okay, please raise your hand. Or if you know the 4 steps, okay, please raise your hands. Okay, Philip, what will be our first step?
Is it to check the sign?
Yeah, very good. Check sign. Okay, because we don't know the angle, right? We want to find the angle, so you cannot start with drawing the angle. So you have to check the sign. And Sophie, what is the second step?
Side ratio.
Yep, side ratio. Anyone else? Only 2 people remember the steps. Okay, Daniel.
Reference angle.
Yeah, very good. Reference angle. Okay, reference angle, we use theta r, right, to represent. Last step, what will be the last step? Anyone else? Found the notes? It's a chance to review, okay? Get to know your old stuff. Anyone else? Only 3 people got it? We had find exact value, and then we have find angles, right? They are backwards, forward and backwards. Okay, Eric?
You check the sign if it's positive or negative.
That's step 1.
Oh, I was not looking.
Yeah, that's the step 1 for find exact value, but now we are finding angles. You have it, Eric? Okay, Claire, how about you? What's the 4th step?
Is it draw angle?
Yes, draw angle and missing couple words. Draw angle in, there's one more word in.
Oh, did we reverse the steps?
Yeah, we reverse the step.
Oh, I see.
So draw angle in what?
I just wrote draw angle.
Oh, okay. Philip, do you have it? Draw angle in,
I just wrote triangle too.
oh, really? Okay. Okay, draw angle in domain. Okay, we'll add this in, okay, in domain. Okay, domain means like, for example, they will say the angles are from 0 to 2 pi. That's called a domain, okay? Or domain is a negative 2 pi to 2 pi, right? Because before we always use 0 to 2 pi, okay? Maybe that's why we didn't write it down, okay? But from this page, sometimes our domain will change. So you can see that we have 0 to 2 pi, and this is called a domain. Negative pi to pi, right? And then later you have other domain, you have even bigger one, 0 to 12 pi, right? So those are called a domain. So you only want to give the answers that are inside the domain. Okay, so everyone please copy those 4 steps down. Looks like a lot of you forgot what those are. Okay, so we're gonna review those, okay? Okay, so please raise your hand after you write the 4 steps down, and then we'll try the questions, all right? Raise your hand after you've written down the 4 steps. Okay, Marcus, you done? Yep, okay. So the question says here, please solve for x. Okay, so x represents the angle, right? Find angle in the given domain. So domain here is 0 to 2 pi, okay? For our first question, this is called the domain. Then find the general solution. So this is something new, okay? Over real number. We'll talk about that later. So depending on the type of the equation, we have different methods, okay? The first method is to isolate variable, and second method is called factor or quadratic formula, right? And third method is substitution, PGG, okay? We'll talk about what that means, okay? Number 4, identity, okay? Number 5, graphing calculator. We won't be using graphing calculator here, okay? Right, so the first one, isolate variable. Variable refers to x, but x is stuck with the sign, right? X is inside the sign. So the variable is referring to the sine x, or the cosine x, or the tangent x, etc. Okay, so x inside the trig ratios. So we'll use that when, okay, we need to fill this out. We'll use this method when there is only one, okay, variable, which means you only see sine, just sine, one single sine, okay, or just cosine. So you have 2 examples here, right? Question 4a, right? You see a sine, that's only one. We see a cosine, even though it's square, but it's only 1. But for question C, you see sine, but you have 2 of them. Okay, for the question D, you have sine, you have cosine. Okay, so those ones you cannot isolate if you have more than 1. Okay, so you will be able to isolate if you only see 1 of them. That's what it means, okay? So for the first question, because there's only 1 variable, right? This is our variable. So we're going to isolate that. So we start move things over, right? We want to keep the sine x by itself. So 2, we can move it over to the right side. Okay, so we'll isolate, we'll write down the step, right? Isolate sine x. So 4 sine x equal to -2. Okay, and then we divide both sides by 4. So you get sine x equal to -1/2. So this is isolate, right? Sine x is now by itself. But it's still not the x we're looking for, okay? So this is the place where we use the 4 steps, okay? So step 1, we check sine. Okay, so is this one positive or negative? Jenny?
Negative.
Yeah, you have a -1/2, right? So sine x is negative. So which quadrant is sine negative? Marcus? Where is sine negative? Quadrant 1, 2, 3, 4.
Hold on. I need to find a note. It's negative in 3 and 4.
Very good. Okay, so we write down quadrant 3, quadrant 4. Okay, so we can move on to our step 2. Okay, we need to fill in the side ratios. Okay, so we draw our picture. Okay, I think you should start to remember now, right? We did this a while ago. Quadrant 3, quadrant 4. The sides, okay, because we are doing sine, right? Sine is opposite over hypotenuse. So our opposite side is 1, hypotenuse is 2, right? Opposite hypotenuse. So we're still missing the adjacent side. We already know 2 of them, right? 1 and 2. How long is the adjacent? Okay, Nick, how long is the adjacent then? Nick, are you there?
Could you repeat the question?
How long is the adjacent side? We have the opposite and hypotenuse is 1 and 2.
Root
How
3.
long is the adjacent?
Root 3.
Root 3, that's correct. Okay, so this is a special triangle. Right, so based on this special triangle, our reference angle is inside the green dots. Those are the reference angle. Okay, so that leads us to our step 3, reference angle, right? So step 3, reference angle. Okay, so our data are, okay, based on that picture, how big is our reference angle in radian? Okay, make sure we're in radian. How do I know it's in radian? You look at the domain, okay? Domain is 0 to 2 pi. So we know they want the answer in radian. If they say the domain is 0 to 360 degree, then you want to answer in degree, okay? So how big is our reference angle here from the picture? Okay, Susan,
30
in radian.
in radian pi over 6.
Yeah, very good. Okay, pi over 6. Okay, final step. Final step is to draw angle, right? Draw angle in domain. Okay, so domain is 0 to 2 pi. That means when you draw the angle, you want to find all the angles that fits. Okay, let me change the color. That fits from 0 to 2 pi. Right, 0 to 2 pi means makes a one circle. Okay, that's the domain. So let's find the angle. The first angle, right, from 0 to 2 pi is this one. Okay, remember if reference angle is pi over 6, then you know each side, right, is divided into 6 slices, right? If it's pi over 6, right? The other side, same thing, divided into 6 pieces. So if it's the first one, right, the first angle that we want to find, it will cover everything up to 180, right, up to pi and one more piece, right? That's the first one. So our first step, right? So our first angle, so x, okay, we can write out the x now. So our first angle is what? Eric, do you have the answer for our first angle?
The 210.
In radian,
Oh, sorry, 7 pi over 6.
7 pi over 6. Yeah. Okay, please remember, do not answer in degree on your homework, okay? Okay, last one, right? Second angle, you have to turn all the way to here. Okay, so that means in your picture, right? You count the slices all the way to here. So what's the angle for this one? Okay, Sophie?
11 pi over 6.
Yeah, 11 pi over 6. Okay, so those are the angles in domain. Okay, we'll box that. We'll talk about general solution later. Okay, so this is called angles in domain. Okay, so let's take a break. Okay, after the break, we'll do another one. Okay, similar to this. And during the break, I will check over your quiz. All right. So I'll see you at 11:20.